SCARA 4 DOF pick and place robotic arm. So our group members are Kajal Soni, which is SAP ID 25, Prachita Punde, SAP ID 42, and Sanjana Parmar, SAP ID 51. And the project is guided by Professor Vivek Nath. So what was the aim and objective of our project? So to design, model, and implement the 4-axis robotic arm, to implement the pick and place operation in a selective compliance articulated robotic arm combination, which is SCARA combination. So this combination is most frequently used in many industrial projects, and it's basically a best way for high speed pick and place operation. What was the objective of our project? First was to design, to model 4 DOF SCARA robotic arm. Second was to simulate the operation of a robot using C++. So over here we did forward kinematics and inverse kinematics equations using C++ language. After that, we designed the creepers for distinct operation, and the assembly and the deployment of the working robot was done using many hardware components. So this is the block diagram of the 4 DOF robotic arm. So what it contains is there are 4 servo motors which we have used for our project, and one is gripper. So along with this, we have used potentiometers to control the robot speed and speed of the servo motors, and we have used Arduino Uno board for further to process the signal from user, and as well as like to send it to the respective motors. Kajal will continue further. And we have used Arduino Uno board for further to process the signal from user, and as well as like to send it to the respective motors. Kajal will continue further.
So the working principle of our autonomous robotic arm is such that we are using the input signals they are given to A0, A1, A2, A3 pins of the Arduino Uno board, and then we are using it to move the respective servo motors. The servo motors are being controlled by a range of values that are being supplied by the potentiometer. Now the potentiometer has a range of values which map from 0 to 1023. These range of values are such that according to the movement, we can then process the variation of angle in the respective arms of the robot. So what happens is that the resistance values get converted into voltage values, which is picked up by the ADC channel of the Arduino board. And then we can finally see the servo motors operating and causing the requisite movement. This is what we see in this given flowchart. So there is start, then we use the Arduino board, then the input signals are taken by the potentiometer, then the 10K potentiometer. So we are using 4 10K potentiometers to work with each of the 4-axis DOF robot. Then it is mapping the range up to 1023, which indicates that there are 1024 possible integer values. Then it is being determined, the integer values used to determine how much the servo motor should turn in speed, and then the servo motors are operating at the 5-volt power supply, and that is how we achieve the requisite motion. Now Prachita will give us the demonstration of our hardware in PO.
Simulating the forward kinematics and inverse kinematics on the C++ software, we also designed a hardware implementation of the 4 DOF robotic arm, as you can see in the video shown here. As you can see, we supplied a 5-volt power supply, and using the potentiometer, we are controlling the angular motion of the servo motor. The microcontroller used here is the Arduino Uno board. And by turning the knob of the potentiometer, we can see that the arm of the robot is moving accordingly. So this is the gripper moving. So as you can see, this is the range of motion shown by the our hardware implementation. We found some discrepancies between the simulation